Hello everyone. So today, normally what I'd be doing is recording some stuff up on the board to help keeping us moving forward towards our next unit, but at this point I've got most everything recorded through chapter 10 and just about ready to post. So instead of doing that, I thought it'd be a good idea to go through some stuff that we have in our homework for this current unit that we're finishing up here for week 7. So normally, over the course of a semester in class, we'd meet and we'd talk about some of these homework problems in there, but because we're not really meeting, we haven't really had a chance to do that. So with this material being a little bit different, a little bit weird, a little bit difficult really, I decided that as we're getting close to this exam, I wanted to take a little bit of time here to go over some of those problems that we might not be able to make time for in that same sort of way, at least not regularly in the way that I would for a normal class, as it were. So what we're going to do here is jump into our Canvas page, and we're going to take a look at some of these assignments, some of these things that, well, we haven't had much time for as a group, as it were. So here we go. First, what we're going to do is jump into section 3.3. There's stuff in 3.4 through 3.6 that is worth doing as well. It's just that, not 3.4 through 3.6, we are going to get that, 3.1 and 3.2. It's just that I kind of have limited time here and don't want this video to be as absurdly long as it would be if I included that. I've already got 9 problems I want to look at here. I want to keep it at least somewhat reasonable, both for my time and for yours. So yeah, I was going to complain about this because I'm going into old assignments. We're going to start here with number 8. I have looked at the others. It's just, well, this was the one that jumped out at me the best for what I want us to see here. So I'm going to start at least with this one because it's pretty short, with just a quick look at how I approached it this time, and then I'll talk through how I'd go through it in a little bit more detail. So in this situation, we're given the statement, you did not mow the lawn and you left the car a mess. It's not a very responsible place to start, but hey, that's what we got in here. These problems tend to be a little bit more judgmental than what I'd normally go for, but hey, it helps to remember. Here, what I would do is recognize this as sort of its own statement there, and that as its own there, which is how we end up with P, you mowed the lawn, and Q, you left it a mess. So this is not P, the opposite of mowing the lawn is not mowing the lawn. And Q, because we got and there, it is that conjunction. And again, Q, like I was saying, is that you left a mess. And then from here, if we want to make our truth table, we have our starting values, TTFF, TFTF, where not P means taking all the values of P and flipping them. So TF, T, F, F, T, F, T. And then for the conjunction, we just look at these two together. So here, since they don't match, the conjunction is false. They are both false. The conjunction stays false. They're both true. The conjunction is true. Then they don't match, so it is false, which means that the statement is only true if P is false and Q is true. Because if we want not P to be true, we need P to be false. So let's get one more quick example here for what this sort of thing looks like. I'm not going to do it for every one of these problems because this one's short. I want to do a little bit of both there to help us get rolling. So we're starting with the statement, you did not do the laundry and you left the garage a mess. Yeah, like I said, these problems are a little bit more judgmental than what I'd go for, but hey, they're set to dad mode, I guess you could say, rather than student mode. Anyway, here, you did not do the laundry, so if we call that statement P, you did the laundry, you have the opposite of it. Then Q, you left it a mess. So let's look at these. So you could do something like this one, number A. You did not for P, but all of these we can tell there are written in terms of the negation of P. What's the word I'm looking for? Multiple choices here kind of limit what you have, but they help a little bit in terms of being consistent with how you can approach these problems. Anyway, you have this idea in this case where if we're thinking somehow in terms of P being doing the laundry, then we have a not P flavored thing as well as an and there. We have a conjunction. So we need P, you did the laundry, Q, you left it a mess, and you need the symbol for and. So that would be what happens in letter D. Assuming I can read. Reading under the stress of recording is going to lead to mistakes, but we'll deal with that as it comes. Anyway, now we're going to go through our cases. So again, we're doing not P. So you take that value P, which is true there, make it false. Here you have T and F, true and false. They have to match and both be true for a conjunction to be true. So this is false. Then we go on to our next one. True, false, but we flip P to false because we're negating it. Then we have P and Q, both are false, so it remains false. Then we're going to go on to FT, which feels like it should be false, but remember, we're negating P, so that becomes true. So we have true, true. This is true. Remember, conjunctions are only true if both pieces are true. True, true, true. Yeah, I'm saying the word true too many times, but that's okay. That's what we got for these types of things. So here, starts as false, negate it becomes true, but we have false and true. They don't match. They're not both true, so P and Q has to be false. And then from here, if we want to make what it means for this statement to be true, we need P to be false because the only case where we get the true conjunction happens when P is false. And we also need Q to be true. So we need P false, Q true. Because this is not one of those self-contradictions or tautologies. It does have its own cases. So that's what we do with something like this. It's just a matter of being careful with our notation and remembering what it means for a conjunction to be true. You need both parts to be true in order for that to happen. So let's jump back over to here, let MyLab complain like it likes to, and take a look at 3.4, where I have a little bit more here, because these are a little bit more involved. I might as well just open 3.5 and 3.6 now, so I don't go through those menus again. So here we're going to start with number 5. I had number 2 on there earlier, but I don't feel like it does quite enough for what I need. So here we need to construct a truth table for this statement, and this one we're going to be really careful with. Remember, for this, we've got something Q, if and only if P, comma, implies Q. So this is a bit circular here, but we're going to see exactly how this ends up going. Where to get the first part, Q, if and only if P, remember for a biconditional and if and only if, we need both parts to match in order for it to be true. Here, they both do, so we're fine. Then we want to talk about this leading into Q again. So it's going to be weird reading this table, but we're going to go this one to this one to this one, then this one back to that one, where we have true, then true. The conditional is true. Then in our next case, let's be careful here. These two do not match up, so the biconditional is false. However, the way we are reading this to finish it off, Q if and only if P, then Q. Silly. This is silly to read that. We're going false implies false because the part that we are using as our precedent, our antecedent here, I think is the word we use in particular, is false. The value for our conditional trivially must be true. Oh, nope, not false. Oh, that was a typo. It should be true. Easy to make that mistake. But remember, if the first part of a conditional is false, then it doesn't matter what happens to the second part. So, next, we have these two don't match up. That means our biconditional is false. So, it doesn't really matter what happens. Again, the conditional has to be true. Because remember, we're going this one into that one. The third into the second, which means reading it kind of weird because we're used to reading left to right, but that's what happens when you phrase something this way. That's why I picked this one, because it's an awkward presentation. And it's also something with both conditionals and biconditionals. I wanted both. Then finally, we have false, false, which this is true because they do match. The biconditional works for any sort of matching. But here, this is the special case for the conditional, where we have the first part is true, Q if and only if P, while the second part, Q, is false. So this is the rare case where the conditional fails. And that's basically all there is for that. You just have to be careful about remembering your ideas for biconditionals, that those are true when the parts match, and conditionals are false only when a true thing leads to a false thing. Because that's what a conditional kind of does. It leads in. It's a condition that you're giving to say something should happen. And if it doesn't, then who cares? It doesn't work. Okay, so let's get one more here from 3.4. We're going to jump out to number 8, which I made a mistake on the first time I was doing this, but that's okay. So we are working here from a real mess of things. This one's very long. It's very, very easy to make mistakes here because we don't get those step-by-step parts. But this is more like what's going to be on the exam, where you can't check your work at every single stage. So here, we are given the collection. P is you'll love the new horror film, Q is you're afraid of haunted houses, and R is you'll find it very entertaining, where we are starting from this clump. You'll love the new horror film, if and only if, oh, that's confusing, they call it a movie here and a film there, that's not helpful. You'll love the new horror movie if and only if you're afraid of haunted houses, or you won't find it very entertaining. So first thing we should notice here is that if and only if between the new horror movie and fear of haunted houses. So you'll love the new horror film if and only if you're afraid of haunted houses. So you've got P if and only if Q, where that comma there says we're taking a parenthesis around that, but you don't really need it because, well, biconditionals are more important than disjunctions, but it's good to be sure. So we got P if and only if Q, that means it has to be one of A or C. And then we're going to look at what happens with R. You won't find it very entertaining is the opposite of you'll find it very entertaining, but these are both not R, so we need to be sure that we know which one of these captures that word there. Or is captured by the disjunction symbol, the V, the one that looks a bit like a U, because remember disjunctions are a lot like unions, talking back to what we did in chapter 3. So this is given by the symbolic statement for letter A. Wait. Yes, for letter A. I told you, sometimes you look at these things and it's the pressure of being recorded. That's what it is. I'm going to say it's not because I don't know what I'm doing. It's because I'm under pressure. Yeah, that's definitely it. That's why I tend to be a little bit forgiving on exams too, because, pressure makes weird mistakes. But let's keep going. So now we get into a bit of a mess here where we got to type in all of our possibilities as we're going. This is going to take a little while, but let's go through carefully. First, we want our part here that captures that relationship, P if and only if Q. So that one. Then we want to capture the whole relationship, P if and only if Q, or not R. P if and only if Q, or not R. The last one. It's a drop-down menu. It's not super helpful for that. But anyway, we're going to go through our stages here bit by bit in the same way we did before, except now we've got all of these to go, so it looks a little bit more daunting, and if you make a mistake, it's a little bit harder to catch it, but we're going to try our best. So, P if and only if Q, we need our two pieces to match. P is true, Q is true. P if and only if Q is true. Not R flips the value of R, so R is true here, becomes false. Then we have P if and only if Q, or not R, true or false. We have 1, that is true. Next case, true, true. The if is not a lowercase t, capital T. The value for R there, false, becomes true. If you have both are true, we're not doing exclusive ORs, that is true. Then we have true, false for PQ. They do not match, so that is false. Meanwhile, we take R, flip the truth value there, we get false. So our disjunction here in terms of these two parts, false or false, is false. Remember that when you're dealing with these things, it might help to just take this clump there that looks pretty bad and think of it as its own statement, like call that T or something. Just something separate, where if you have one part's false, second part's false, it doesn't really matter that it's more complicated getting there, it's still going to be false because it's still a disjunction with two false parts. Then we go on to here. We have true, false, non-matching, so not disjunction, the biconditional must be false. Then we have false here. That false becomes true because the opposite of a false thing is a true thing. We have false or true. That is true because one of them is. Then coming down to here, we are still not matching. That's the thing about biconditionals, so they don't tend to be true very often. It takes a lot to be sure in both directions. That's going to be false. And here, true becomes false, so our statement is false. Whew, got a couple more. Then down here, false, true, non-matching, biconditional is false, false becomes true, and finally, false or true, just need one, that's true. Then for these two, we can see that's false, false, and false, false. So I'm going to skip a little bit here. That's true, and that's true as well, both for the same reasons that they both match. You get the trivial trueness in both directions, as it were. Then here, that one true becomes false. T or F is good enough to be true. Then down here, false becomes true. T or T, that remains T for hopefully clear reasons. And I really hope I didn't make a mistake on one of these because these are a pain to check. Okay, good. I know how frustrating that is to go through if you make like a silly mistake, or if it doesn't like your tensing, or you throw a space in there. It's really silly and annoying, but it's what we've got for the circumstances. Anyway, to then see what makes this statement false, we want to find our two cases where this whole thing was false. And it was false when the parts of the biconditional didn't match, and we had that not R was also false. The other way we can say not R is false is that R is true. So we need P and Q to be different and R to be true. So looking at our options, P and Q has opposite truth values. That's part of it, but not enough. The same is false when R is true, P and Q have opposite truth values. That seems closer, but they wrote it in a weird order. R is true, P and Q have the same truth values? No. False when P and Q have the same truth values? Definitely not. No condition exists to make the statement false. This is not a tautology. It can be false. So our answer here is B. I don't know why they put R first, but that's what we're looking at. So that's how you'd approach stuff like this. You just have to be very, very careful going through all of your cases. If it's not entirely clear what you're looking at, just break it down into smaller and smaller parts as you need to. The point of a truth table is to show all of the options in as much detail as you could possibly need, and almost certainly more than you'd actually want. It's just about going through these things very slowly and getting everything in there as best as possible. Hopefully that helps clarify some of the problems. So let's look at the most difficult, most advanced, most involved thing you can do with these ideas, with truth tables, looking at what we want to call equivalent statements. I'm going to close out 3.4. I'm going to jump into here. We also get variations on conditional, so we got a lot to do in this section, but let's start here with a fairly direct one, I think. It's been a while since I looked at it, number 2. Ooh, this is one of those really long ones. This is why I picked it. It's long. You got a lot to do here. So you want to use a truth table to show that the statement P or Q and Q implies P are equivalent. And this is kind of a funky looking thing that we're doing here in terms of saying that not quite the converse works there, but it's a bit like a contrapositive almost. It's a little weird. But let's go through our steps here slowly, because we want to show that something is true. So we have our two statements, P and Q. If P is true, not P is false, not Q is false. So P or Q must be false. And then we have this horrible looking one, not Q leads into P, where we have not Q, so P or Q, not, oh god, it's really easy to mess this up. P or Q here, these are both true. Sorry about that. Like I said, this is really, really easy to make a little misread error here. Take it slowly. Anyway, here we have not Q, so that's this guy. Leads into P, that's that guy. False into true, that's good enough for us. This is actually true. And we're going to keep going here. True, false. So true becomes false. Then false becomes true. P or Q, we have 1, that stays true. And then we're looking at not Q into P, true into true. That's our best case for conditional is true. Then from here, let me actually zoom in just a little bit because these are a little small. I can give you a little bit better of a view. False becomes true. True becomes false. P or Q, false or true, good enough for us. And false into anything for a conditional guarantees truth for no good reason. Well, not for no good reason, but because we can't do anything useful. Then we have false, false. So not P becomes true, not Q becomes true. P or Q stays false, and not Q, true into P, is true into false, which is the base false case for conditional. So we have all of these here, which does show what we want, which shows that all of these things are equivalent. They have the same truth value. This is what you want to do for showing equivalent statements. A lot of these in the homework just say show it, but they don't ask you to actually go through the steps, so you might just guess your answer. This is what you're really meant to do, and there's probably going to be a question like this on the exam. So be careful about understanding what it is we want here is to see that these two columns have the same T and F values, that they're true at the same time, false at the same time, because that means they have the same logical meaning. So, which statement is equivalent to the given statement? The given statement is you are not inside, or you have a roof over your head. So P would be something like you are not inside. Q is something like you have a roof over your head. So we want not Q, you do not have a roof over your head, implies P, you are inside. Which is weird, but that's what we're working with. So, if you do not have a roof over your head, reverse of Q, that only comes up here, but that's okay. Then P, where P is, you are not inside, excuse me. I got ahead of myself. There's so many negatives in here. It's negatives and negatives and negatives. But yes, I remember I said P is that you are not inside. It has a negation inside of it, so we're going to keep that negation. And it's a statement that makes more sense now. If you do not have a roof over your head, then you're not inside. Sure. My mistake. Like I said, there's a little bit of pressure here doing this stuff live, but hopefully this is helping. Anyway, that's what we got for number 2. So let's jump to something a bit more... Well, I'm not sure if it's involved at the top of my head, but maybe with a different sort of flavor, where, this is a fun one, where we're trying to talk about equivalence of things between disjunctions and implications. That we have I saw the Titanic or Braveheart, where this kind of leads off from what we saw in that last example that develops from our idea from number 2, where let me just flip back to that one so we can remind ourselves about how that works. That, go away, save this attempt, I'll be back. That we have a disjunction is equivalent to a certain kind of conjunction, and this also fits well with the idea of negating conjunctions, that the phrase if P then Q is the same logically as not P or Q. It's kind of like what happened in this part here, just with a different sort of order. Different things are and are not, as it were. But here we have P is something like I saw the Titanic. Q is something like Braveheart. I saw Braveheart, I guess. So P would be this guy. If we want the opposite of that, we would want something like I did not see the Titanic, where you could say ultimately a statement like if I did not see the Titanic, then I saw Braveheart, which should make sense because those are options you can't do at the same time. I don't remember if those movies came out in the same year, but yet again, we are in a bit of dad mode for talking about movies from the late 90s. Still, the idea here to take away is that a disjunction is logically equivalent to a certain flavor of conditional up to being very careful with negating one of the statements. And we'll see more about that when we get to the stuff in 3.6. Anyway, got one more in here. That is number 10 that I'd like to look at. So this is about converses, inverses, and contraposition. So if birds flock together, then there must be an early worm. All right, sure. We're gonna mix up 2 aphorisms here. So the converse, when we're looking at these statements, is essentially just flipping them around. It's flipping around the ideas that we're looking at there. So you just take each part, reorganize them. If P is the birds flock together, Q is there must be an early worm, then we would get the converse by saying if there must be an early worm, then the birds flock together. The converse is just a matter of flipping the order. Then, if we want the inverse, instead of flipping the order, we flip the value of each part. So we take our first part, if the birds flock together, flip it. If the birds do not flock together, then there must be an early worm, flip it, there must not be an early worm. So we get in total, if the birds don't fly together, then there mustn't be an early worm, which we have something like this, assuming I can read, which I've been looking at a lot of these. It's a big ask. Thankfully, I still can, though. And for the contrapositive, we're essentially taking both of our first 2 parts, the inverse and the converse, and sticking them together. Where the contrapositive gets us a thing that's actually equivalent to our original statement by rearranging and killing the antecedent-precedent relationship. Antecedent-subsequent, relationship. So what you do for the contrapositive is you flip both parts, then you flip the truth of each part. So we put the early worm first, take the reverse of it, birds flying together, take the reverse of that. So you'd have something like, if there mustn't be an early worm, then the birds don't fly together. So to start with not having the early worm, if there mustn't be an early worm, then the birds do not flock together, which looks like is what we get in part A, where this part B is something more like that equivalent disjunction idea, and this one, if there must be an early worm, then the birds flock together. That's more like the converse that we saw earlier, and if the birds do not flock together, then there must not be an early worm, is that inverse we saw earlier. Remember, for the contrapositive, we are taking both things. So even though this or thing is actually very, very similar, and both of these are other related constructions, only A is what we're looking for here for specifically our contrapositive. It's a lot of patterns to remember here. It's part of why I'm letting you guys have your notes on there, just so you make sure that you remember these definitions carefully and you get what you need. So that one taken care of. Let's jump in and look at 3.6. So for 3.6, I've got another set of 3 questions here. We'll start with number 2, which I have done. I need to generate a new question at the start, where we want to negate the conditional statement. Like I said, conditionals are equivalent to disjunctions because with a conditional, we need to have, in order for it to be false, that the first part is true and the second part is false. So you can write a conjunction thinking in terms of De Morgan's laws as something like the first part is false or the second part is true. Because if the second part is true, it doesn't really matter. And if the first part is false, it can't matter. So if we have if I am in Nantucket, then I am in Massachusetts. This is a standard if-then conditional, where the equivalent disjunction flips the first part, it negates it, then just allows the second part as it is. So I am in Nantucket and I'm in Massachusetts. That's a conjunction. That is an and statement. Not what we want. I am in Nantucket or I am not in Massachusetts. Close, but this has the wrong part negated. Remember, we want the first part negated. I am in Massachusetts or I'm in Nantucket. That just flipped them. That does nothing for a disjunction. If I'm not in Massachusetts, then I am not in Nantucket. Well, that's the contrapositive, which is good. If I am in, I am in Nantucket or I'm in Massachusetts, that's just taking the thing and putting an or in the middle of it. That does nothing. It's a different sort of statement. I am in Massachusetts, but I am not in Nantucket, which is interesting. That's something like a P and not Q. Then I am in Nantucket, yeah. I haven't spent enough time in New England. I am in Nantucket and I am not in Massachusetts. That is Q or P and not Q. Okay, that's something. And then finally, if I am in Massachusetts, then I am in Nantucket. That is not the negation. That would be our converse. Converse of a conditional statement is not it negated, it's just it rearranged. So if we have that the statement if P then Q is equivalent to not P or Q, then if we need the negation, we want to negate P, so we want P to stay the same because we're double negativing it. Then using De Morgan's laws, when we flip or, that becomes and Q gets negated. So if we want the negation of the conditional, then what we want is P and not Q. So we need to be in Nantucket and not be in Massachusetts. I am in Nantucket, not in Massachusetts. Which is a little silly because that is where Nantucket is. But that's the idea there. Just be very, very careful and understand how you can connect conditionals with disjunctions and conjunctions. And then De Morgan's laws as well. That comes into play too. So let's jump here to number 5. Where for number 5, we are going to actually use De Morgan's laws. Where we have a bit of a silly statement here. It is not true that the baby and the puppy both want to go outside. So we're taking something like the baby and the puppy want to go outside and throwing that little negation squiggle out on the front of it. So we have something like not quantity P and Q. If you bring that not into there, you would have not P as well as not Q. And then in the middle, you have the and here that it might not let me highlight. Oh, it's cool, it did. You also have to flip the and. Flipping negating, to be more specific, a conjunction gets a disjunction, negating a disjunction gets a conjunction. It's just like with in chapter 2 when we had those De Morgan's laws. If you wanted to get the complement of a union, you got an intersection. If you want the complement of an intersection, you got a union. Same thing here. So the baby does not want to go outside. The puppy does not want to go outside. And becomes or. Baby wants to go outside or the puppy wants to go outside. You got the or, but not the things on the outsides of it. You only flip to the middle. The baby does not want to go outside and the puppy does not want to go outside. The and remains. This is a mistake a lot of people made on the pre-assessment, that the and is an important thing that has to change here. If the baby wants to go outside, then the puppy does not. That's something else. That's again talking about the relationship between these types of things in conditionals, where finally for part D, the baby does not want to go outside, opposite of the first part, or opposite of and, the puppy does not want to go outside, opposite of the second part. So D is our answer here. And then we've got one more I wanted to do for now. So hopefully we're going right along here. I know it's a half hour of watching me do homework is very exciting, but hopefully it does get you what you need in terms of being better prepared. So for this, we want to think very carefully in terms of equivalent statements. We're not going to go through the entire truth table here because, oh boy, would that be a long truth table. But we can figure out in terms of understanding the relations between conditionals, conjunctions, and disjunctions if any of these say the same thing but in different words. So, if flowers are blooming, if flowers are blooming and Ross is chipper, then Rosemary is chipper. This is weird. It's very like first grade learning your letters, but it's what we got. So we have something like if P, the flowers are blooming, then Q, parentheses, or excuse me, if P, the flowers are blooming, and Q, Ross is chipper, then R, Rosemary is chipper. So we have if P and Q, then R. For our second part, we have if Rosemary is not chipper, then it is false that flowers are blooming or Ross is chipper. This one's dumb. This one is, let's see, I said Rosemary's chipper is R, so not R implies the grouping with a negation in the front of it, P or Q. If you bring that in with the De Morgan's laws, that would be something like if not Q, then not P and not R. Just clunky and not at all like what we had in part A. It's a lot more involved. You have way more parts there. No, that's not what we're looking for. Then finally, flowers are blooming and Ross is chipper or Rosemary is chipper. So that is P and Q or R with a parenthetical around the conjunction. So nothing at all with conditionals there. The only ones that could have any real relationship might be something going on between like that and doing something else there in terms of like this connection, that if P then Q is the same as not P or Q. But the problem is here that if not P, so if not R technically, then it is false for that thing, for the other part. So Q here would be flowers are blooming or Ross is chipper. Like I said, you have to sort of really chunk these things together, but it just doesn't flow in the way it needs to. And then for that matter, for the first one, we would have something like if P then Q, or excuse me, if P and Q, be careful about my wording, then R, which is not the same as P and Q or R. Because a conjunction is not just the same as, or excuse me, a disjunction is not directly the same as the implication here. That P, the flowers are blooming and Ross is chipper, needs a bit of a negation to be the same as this one there. We don't have that. So A and C, not quite the same. B and C, not quite the same. A and B, definitely not the same. None of these are actually equivalent. It's just messy to be able to see that. It's probably better for something like that to actually write out P, Q, and R, what they look like, and then like think through to yourself what sort of negations are going on there. This is not an easy example, though. It's why it's in the homework, because I like giving you tough stuff for that, even though it just comes down to multiple choice between some people probably guessing their answer, but I'm not going to think too much about that. Anyway, that's the main things I wanted us to get here. That's the main things I wanted us to look at here, to get some more homework practice to make sure we're feeling a little bit better going into our second exam. Be sure to get that pre-assessment done when you have the time. Email me if you've got any further questions. Otherwise, have a good week and good luck finishing up for that second unit exam. See you all in a bit.